All right, we're starting the stream here. Let me post it on Discord. All right, so kind of picking up where we left off from before. Just one minor thing. In my van pool today, I fixed a bug in CXT. This is the documentation engine. So this is all written in a language defined for the project. Oh, yes, this is incorrect. Let me fix my my camera real quick. Yeah, it's on the wrong one. Properties. No, it's on the right one. Sorry. All right. Discard the changes. Okay. Oh, it's not sharing my screen right now. Let me fix that. What is going on? VL2. Here, 1 second. I'm gonna end the stream for a second. All right, there we go. All right, there we go. Apologies about that. Let's see if it goes back up. Okay, I think we're back online. Let me just open Discord as well, and let me join Discord. Okay. I will mute the Discord chat for now, just in case. All right. So, all right. So I fixed a small bug with CXT. It was formatting inner code blocks. This is CXT. It's the documentation language of Civ Boot. I'm not really that happy with the HTML. Gosh, is this going to close? Oh, okay. So you can see it at lua.civboot.org, package CXT. Yeah, it's a text markup language. The documentation is here on how to write it. It's kind of similar to Markdown. It is inspired somewhat from BB Code, which is an old forum software. It's very simple to write. I'll probably do a podcast on just CXT at some point. But for now, let's get back into programming in Ellie. So we want to be testing command tests. Test session is probably going to be our main one for a long time. So we just run our test before we start. And yeah, let's actually program in Ellie. Oh, there was an error. Oh, this is that same error that we were having last time. Maybe we should try and chase this down, because it's rather annoying for this to be failing every once in a while. So first let's copy paste this so that we can kind of see. Let's grab a few more lines if we can. Okay. Let's put these in temp coerror.txt. And I'm not going to start Ellie yet. I'm going to try and fix this. I find that fixing bugs when you have a feature, an editor that's not quite ready, is particularly annoying. I like to stay within something that I'm used to. Okay, so anyway, this says that when creating the buffer, two coroutines are both attempting to listen to file no 3. So let's find where this error is coming from, which is, I'm pretty sure, in our lap protocol, which I can talk about. Lib lap.lua. Yeah, and it's right there. If I didn't know where it was, I have a find fix utility, which is similar to grep. I mean, you could just use grep-r as well. And I could type in the command correctly. And it would also find it. So you can see that that has syntax highlighting. It has some other features too, like find and replace, which we're not going to use right now. So anyway, that's also a Civ boot tool. So 2 row coroutines are both attempting to listen to file no 3. Okay, and then it says existing traceback is %s. Okay. And that's all it does. It returns, oops. So it's getting the debug trace map from the coroutine of pull map file no. I should be printing both though. Yes. So what I should be doing is I should be doing local t equals, and we'll move this into here. We'll push a new line onto it. And then we're going to extend ds.tracelist oh, this is like, okay, sorry. Let's back up here a second. This is all inside of the string.format. format. Okay. So we're actually going to do, sorry, local t equals, let's like just, we're going to craft the error message in the table. So this is something you can, when you're creating strings in Lua, it might be maybe unexpected, but the fastest way to make a string in Lua is actually to create a table of strings and then call table.concat. And although that requires creating a table, it is much faster than many alternatives. So we're going to do ds.extend t the trace list here. We're going to push a new line onto that, obviously with t, and then we're going to also ds.extend t, basically the same thing, except it's not going to be the pull map, it's going to be our coroutine that we're accessing. And this was returning a string before, so we're going to return table.concat. Let's see if I'm importing that. I'm not. Let's import that. Push concat. Just keep an eye on comments. Push and concat. We're just gonna return concat, and then that'll end that. Okay, so the next time this happens, we're gonna get to see both coroutines that are causing this. And we'll get to see it separated by, we're going to get to see it separated by those. So if this error appears again in the future, we'll be more prepared for it. So I'm actually not going to try and debug this now. I'm going to wait till the error appears again. And we probably won't get to see it this time. Let me grab a drink. It has to do with threading. So this happens in coroutines, which are kind of like threads. And normally coroutines make things a lot more deterministic. But we have very specific requirements. Programming speak is invariance for specifically how file descriptors are handled, that we don't allow file descriptors to be accessed by two threads at the same time, which I actually think is a very good requirement. It's not strictly unsafe per se, but it would likely lead to unexpected behavior anyway. And just the way I've implemented reading, it requires that you basically have only one coroutine waiting on a single file descriptor at a time. Or a file descriptor can only be waited on by one coroutine at a time. So it just is much more convenient. It makes it a lot easier to program that, and it's also actually probably better. So I'm not going to change that anytime soon, if ever. Probably never, because I actually like it. I like that this is throwing an error. It's actually good that this is throwing an error. So anyway, let's get on to programming at Ellie. I'm not sure how old this session is. I'm just going to close it. All right. So the next thing that we were working on, let me just look at my notes real quick, I'm pretty sure the main thing we want to do is implement repeat. So repeat, if you're familiar with Vim, it's the dot syntax. It lets you repeat the last action you did. So for instance, if you insert hello and then you exit insert mode and press dot, it'll insert hello into wherever your cursor is. Or if you change word and then insert hello, it'll, delete a word and insert hello when you press dot, which is really useful if you have some text you want to replace. There's only like 2 or 3 instances of it. You can replace it once, and then you can just find next and just hit dot and replace the next one. It's something I do all the time, and I want it to be supported. And then also we can build macros on top of this dot syntax, which macros are cool. We want to build macros. Yeah. So, all right, let's see here. I think my mic is off. Okay, can you all hear me in the Discord right now? Should I mute the Discord, my voice in the Discord? Or I think you should just mute the YouTube so you don't hear my voice twice. I think that's going to be the best way, because the YouTube is going to have a delay of like 3 seconds. I mean, the nice thing about this is you could just ask me questions and I can answer them. So if you're interested in asking questions. Yeah, I think I prefer the voice. I'm bad at checking things like chat. Yeah, but it's up to you. It's your choice. I should not be streaming your voice. I believe you're muted and nobody should be able to hear you. If you want to be heard, let me know and I can broadcast your voice as well. All right, awesome. We just have someone joining in on Discord, so I'm chatting with them. All right, so what we're going to implement here, I'll just continue if that's okay. Let me know if you have any questions. We're going to try and implement a dot for Vim, which is the repeat command. So the first thing, and I have some notes here. So basically, I need to have something that. The first thing I need to do is when events happen. Let me just talk real quick about the architecture of Ellie. So package Ellie, I have it documented. It's not a lot of documentation yet, But the basic architecture of Ellie is in the MVI model. And this is half for me and half for you. I need to refresh myself a little bit. The MVI model has model view intent. So I like to start at intent. Intent is you press a key, or maybe a timer happens, or maybe like something comes over the network. It generates an event that gets pushed on a serial channel that gets handled sequentially one at a time. So that goes to the model. Now the model is a set of data and specific key bindings and actions to do when it receives events. So the event gets executed in the model, and that changes the model. So it changes the data. It might insert some text. It might change to a different buffer, things like that. After it's done, it goes over to the view, which paints the change. And then after that, the user, of course, looks at the view and maybe presses a new key, and that again generates a new event, which gets handled in the model. Now, the other thing is models can generate their own events. And so this model view intent, where in Ellie's case, events are plain old data, which means that they're just tables, raw tables that have just like strings and integers, no functions, no meta tables, no complex types or anything like that. They're just plain old data. So we could eventually, we don't currently do this, but we could write them to a JSON file. We can replay them, we can store them, and we can log them. It's very helpful for them to be plain old data, and that's the architecture of Ellie. So let's go back to Ellie here. I started in the bindings file, but actually we're going to have to update the editor file. Or sorry, I think we're going to have to update. I think it's the editor file. It might be the actions file. I'm going to actually, I think I'm going to stick with Vim. As cool as it is to use Ellie, I think I'm going to stick with Vim because it has syntax highlighting, and it's just better to read. We are going to be adding syntax highlighting to Ellie very soon. Actually, on that note, maybe adding syntax highlighting is exactly what I should do here so that we can use Ellie sooner in this. I apologize for going off on the tangent of the model view intent. I think we're going to add syntax highlighting, which I hadn't really planned to do, but I think that's the right thing to do. Okay, I have a plan for how to do this. I haven't thought about it in a little while, except abstractly. Let's talk about Peggle. Peggle is Civ Lua's library. Let's open the docs. I'm not sure if the docs are very good, but we will look at them briefly. It's a Peg is a parsing expression grammar. It's one of the most common and simplest ones. Peggle is a Peg-like parsing expression grammar that is written in Lua and uses Lua syntax. The goal of parsing is to convert a string like this into like a list of the operations, the tokens, and their abstract syntax tree so that you can then inspect it. For syntax highlighting, we don't need a complex abstract syntax tree. All we really care about is what kind each symbol is. And we're going to ignore things like op. And we don't need to be very extreme, like it doesn't have to be perfect syntax. In fact, we don't want it to only be able to parse perfect syntax, but we would like it to maybe give hints when the syntax is wrong. So we want a little more forgiving syntax parser. Fortunately, we already have a parsing expression grammar in Civ Lua, which is Peggle, and Peggle has a Lua parser, which is peggle.lua. I did this because I knew at some point I was going to want to parse Lua in order to write a compiler and also to write syntax highlighting. So probably the best way to explain Peggle and also to get me familiar with what we're even doing here is look at the tests. So if you parse, for instance, 420x3a, you get a number and a hexadecimal number. list. So this is a little testing helper that I have. Basically, you give it some data, you give it the specification, which is 2 numbers in this case. I mean, we're being very explicit. Normally you wouldn't be this specific. This is like a unit test. And then what you expect, and I have some helpers to generate these. These are both just tables that have kind equals num, I think. Yeah, so it can parse Lewis strings that are fairly complicated. It can parse fields. It can parse tables. It can parse expressions. And actually, it can parse every single file in Civ Lua. And it does so every time I run unit tests. I believe I walk the whole tree and parse every Lua file. So it can parse all known Lua syntax that I actually use. So there is a question in Discord. Yes, the goal of Civ Boot is to create a factory where a limited group of people could manufacture their own computing technology. Not mimic most modern technology, but basically the technology should be good enough to build the Civ Boot, and also it just needs to be good enough to build a Civ Boot and a CPU. I believe for that to be achievable, you need about like a 1990s computer chip and display and stuff like that. To answer the question of what Civ Boot is, we are just going to focus on the software mostly in this stream for a long time. I will do podcasts where I talk about Civ Boot more generally, but that is going to be the main focus, I think. Okay, so we would like to we already can turn Civ Lua into, or sorry, any Lua file into these abstract syntax trees. So all the architecture is going to be is basically we're going to parse the file. We're going to pull out the kinds. So we want to key on certain kinds and add a color to those. And then we are going to write the colors as what's called ASCII color, which is another package written for Civ Boot. It's a specification that maps single characters to colors, bold or uppercase or bold, or if in the case of the background, uppercase is underlined. Is that going to work? Here, let's do I'm going to use the local version here since it's going to be a little quicker. I don't know why it's loading so slowly. Okay. So yeah, you can see the full mapping in ASCII color here. So basically we just want to map a text file to a grid of its colors. And then we need LE to display that. If I open LE, you can see that it already supports color because the, here, I'll just open LE real quick. Actually, you can see it right here. You can see that the number lines are already colored and highlighted. Although I didn't highlight the bottom, which I meant to, but I never did. Anyway, that will be the future. Okay. So I think right now, the main thing we're going to focus on after all of this introduction is making sure that our kinds map to something in ASCII color. So jumping right back into ASCII color, we also have something called style, which unfortunately is for some reason not being generated. Oh, it's being generated here. That is a bug. We can open up here. UI ASCII color, ASCII color.lua, style. Yeah, so these are the different styles that we currently support, and of course we can add other ones. So you can see each style, for instance, a call maps to a C, and if I go back to our handy dandy table right here, we can see that C means it's a cyan color. So a call, like a function call, would turn into a cyan color. All right. Yeah. So let's jump back to Lua.lua, which is, oh, that's the wrong Lua.lua. That's our documentation. We actually redocument a lot of internal Lua functions there, but we're not doing that today. Okay, so let's take a look at what our names are. So name is num, and let's look at ASCII color and make sure that they are mapping up. So I assume I have num, but it's called number here. Let's fix that over here. And then we'll have to fix the test as well, probably. Oh, that's actually going to affect other things. Let's fix it here, and then let's see if we're using it elsewhere. So the only place this would be used would be in the formatting logic. Num format. Number. Here, I can actually narrow it down for myself. Like that. Okay, there's two places I'm using it. Line and number. Lib format.lua. So you can see the way, one API for this, and that's how all of this text is highlighted when I print it to the screen, is this one. You have a format object, and if you call styled with the style, it will run it through the VT100 terminal codes and do the right thing for you. So we're going to change this to num. That's our only use of that. Great. Well, that was easy. Okay. Let's go back to our styles. A keyword. Let's see here. That one is called keyword. I think that's probably, let's keep that one the same. So I probably can only look in Peggle, so I can go a root lib Peggle. Here, I'm going to clear my screen each time so that I can only see. It doesn't look like I use it very often. Let's make sure our tests all pass. So I don't think I was actually using that. Oh, there's our yield again in Ellie. So you can see we have a better error now. We know that we are accessing in two places. This is a rather annoying bug. I think I'm going to disable this test for now. I'm going to copy this. I'm going to put it in my temp, co-error. Okay, so I'm just going to put it in there for now. The actual test that's failing is 269. So we're just going to disable this for now, because I don't want to see that every time I run my suite while I'm changing another area of code. Sorry, I'm used to max now. That was the wrong thing. All right, 269. Yeah, the nav test. And we're just going to put a fix me here. Okay. So I think it should pass. Great. All right. So So there's a lot of code here, but it's built incrementally. And this is generally how you do software development. You have to think about each problem and kind of unroll the problem into smaller problems until you can solve all of them. So, Peggle, test Lua. So these are our tests, and we're going to continue to look through the, so you know what, I think what I'll do is I will look through these offline and make sure that they match with the kind and the format so that it's set up for formatting. The main thing that I want to do after that is, because this is going to be pretty mechanical, not that interesting for anyone watching. The main thing that I want to do after that is I want to be able to handle bad formatting. How do we handle bad formatting? So the way Peggle works, the way Peg works, is let's just do a simple Peg. Let's see here. Do we have a good example? No, let's actually do the Lua one. Sorry. Yeah. So a number can be any of, that's what the or means, a base 16 number or a base 10 number. So the way the parser works is it looks at a character and says, does this look like a hex number? Meaning, does it start with 0x? If it does, then it's a hex number, and it returns that. If it doesn't, it looks at whether it's a base 10 number, meaning are all the characters between 0 and 9? If it is, then it returns it as a number. And then the way that those are implemented is, so if we look in here, so base 16, it is also just a list, and what it does, it says unpin, which means don't throw an error if you miss anything, or if anything doesn't match, just go to the next value. Basically, don't panic. Just return nil. Check if there's a negative. There might be a negative. There might not. Check if there's a 0x followed by a 16 pat. These are Lua patterns. So 16 pat is A to F, capital A to F, or 0 to 9. Any number of those. And check if there's a period followed by another 16 pat, which would be a floating point hex, which would be kind of weird. But anyway, if those are found, it will return the tokens. So each of these things will be their own item in the list, and the kind will be set to base 16. And since it's wrapped inside of this, the name will be set to num. So the kind will be base 16, the name will be num. Okay. And then statement is empty here, and the reason it's empty is because we eventually add to it later. So if we look, we extend statement here with a bunch of things that could be statement, and statement is of type or, meaning any of them will become a statement. Okay. So what is this to say? This is all to say that the way that we parse Lua, there's a single root function that we normally use when we want to parse Lua, and we expect it to be valid code. And that function is probably used in test Lua path, assert parse spec equals source. Okay, source, this is a little trick. Basically, source equals peggle.lua.source and m.source. Oh, it's right here. I almost never do it this way. I can't remember why I did it this way here. I was having some issues with local variables or something. Anyway, m.source equals source, and source, what source expects is a block followed by an end of file. Basically, a Lua source code is the block of a function. That's actually what Lua source code is. Now, is the stream having issues? I can try and adjust the settings again if it is. Anyway, so basically this is all to say, block is overly judgmental for source code highlighting. We want something that's a little, oh, go ahead, sorry. Okay, YouTube was showing me an error that it was having problems, so, but it's not. Good, thank you. Okay, so it's overly explicit for source code highlighting. So let's take a look at the definition of block. Let's actually use our handy dandy find fix to see how often this is referenced. So we set the root to Lua and we're looking for block. Okay, so block is this. It's not extended anywhere actually. That's the whole definition. I thought it would be extended. A block is many statements. Wow. And possibly a last statement. Yeah, it's not a lot. That's the entire definition of what a Lua block is. Last statements are things like return, I believe. Oh yeah, return or break. It's right here. So last statement can be either return or break. Okay, so that's what a block is defined as. Our parser will error if it does not encounter a statement. We don't want it to error. We want it to just continue on. So how do we do that? Well, we don't actually care. We will basically say, if it's a statement, then great. So we're going to do an or here. We're going to allow it to be a statement. We're going to allow it to be a semicolon. We're going to allow it to be a last statement. Basically, we're going to get rid of error checking. We're going to allow it to be just the function keyword by itself. And this is kind of silly. We're going to allow it to be just the end keyword by itself. You would never want to actually program a language like this, but it is good to program a syntax highlighter like this. Now, we don't actually want to program the syntax highlighter exactly like this. So basically we want all of the keywords to be supported, which are right here. And what we're going to do is we're going to say unexpected keyword. So that's going to override the name. Is that going to be the rest? Okay, let's actually, sorry, let's do, let's move this here. Let's have it be a different name, but the same data. So this is just a list of our keywords. And this is going to be the same thing. And I like to line these up as columns. I know that is a weird thing. It's something that I've been experimenting with in this code base, and I think it's much more readable. I like to even line it up here. So the unexpected key word will be after this. This is why I hate Vim. Look at how bad the syntax highlighting is. And that's because Vim uses regular expression parsing for its syntax highlighting. I'll fix it in a second. Let me just unexpected key word. What else do we want to support? We will support any non-white space character as an unknown symbol. Oh, we should probably support parens as well. Unexpected parens. Yeah. Let's do it here. Local unexpected group, let's call it. And this is going to be unexpected group. And this will be open parentheses, close parentheses, open and close brackets. So any of those, if we encounter them and we haven't seen their light, then we want to basically throw an error there. What else? What else could we encounter? I guess any of these operations here. Let's put this all here because that's the only place it's going to be used. Yeah, I wanted the group to be kind of its own thing. I think now it's just anything. So pattern. I think this is just. I think I can do name equals. I think these are pretty clever APIs here. We're just going to do unexpected token. And this will be literally any non-white space token. We'll call this token as well. Okay, so that's loose, and a loose block is going to be any loose. that's it. I'm going to switch to doing it this way. Sorry, this was... Okay. I like to export these so that I can put them in tests and stuff. Many m.loose. Oops. Okay. See if that passes our test. So basically, we expect that this loose block, and I might end up renaming this to something else. Basically, it's loose parsing. We expect that this loose block will literally just never die. Like we could put any text we wanted to it. We could put we could put comma separated values. We could put HTML. We could put smiley faces. Actually, I'm not sure if it would handle smiley faces. I mostly have been testing ASCII so far. Eventually, I'd like to support Unicode. But we should be able to put basically anything into this, feed anything into this parser, and it will at least not die. And it'll try its best to give us like whatever it can kind of detect as Lua. And more importantly, maybe, if it sees an unexpected keyword or unexpected group or unexpected token, those will be special things, and we're going to assign those a syntax of error or similar, so that when I'm editing and I have a dangling end or a dangling parentheses, that will show up as, hey, dummy, this thing shouldn't be here. So that's the goal here, that's the design. So let's just write some tests now. So basically, we're going to write some tests in our test Lua. Let's put it before parse source. So we actually have a test here that tests error cases. It's testing that this is invalid because it has the comma. So we're going to be doing something very similar to that. Oh, this is Civboot's error library, by the way. I have the new index. I'm very clever here. I don't know if I should have been this clever, but I rather like it. If you assign a new index to it, it actually runs the function that gets assigned to it, and it just lets you save a few symbols. It looks cleaner in my opinion. I like it. So basically, this will run as a test. So if we just do assert false here, and let's make our test libpegel test Lua, so that we hit it sooner. It'll fail, and actually I have a specific little thing that I wrote called yeet, and that will print out this nice yeet that we failed there. That way we're not running our entire test every time. We're not running our entire test suite here as we're developing this. Just like makes it a little faster to iterate here. So basically, let's take this this code, bad Lua, we'll call it. And we're going to put it right here. Okay. And then this can be a little shorter. Okay. That failed. Why did that fail? Bad Lua. Oh, the line was different. Oh, the indents are different. Huh. Bad Lua. Air expect. Well, look at that. We can just copy paste this. What is the difference between these? 2.16 and it moved over by 2 blocks. Looks okay. Is there anything else? Let's just do a comment block here. Is that the only error? Now all of these have just slightly different numbers, I guess. That's really annoying. Oh. Let's just do this. We'll just get rid of all these stringified things. And do that. Oh, okay. Is that better? Ah, man, I've got to fix the output there. A table, oh, there's an extra quote. Oh, that quote was copied over. Wait, where'd it go? Go with quote. Did I do that so fast that there we go. All right, now we're yeet okay. All right, sorry about that. All right, so we just showed that we expect that to fail. We do not expect it to fail if we use loose. So spec equals m.loose. Not text. Bad Lua. Okay. Right. So although we expect lots of things, there's a little more work that needs to be done to make a truly relaxed parser. I know exactly what needs to be done, I think. No, maybe I don't. Basically, every single item inside of it needs to be considered unpin. It needs to not error in this case, which I think actually should probably just be a global setting to say that it's in loose mode. I am happy that we added those catch-all cases so that we can show kind as error. But oh, it is late. I gotta quit the stream here. So I think I will do this next time. I will probably add a loose mode to the Peggle parser that will basically ignore errors. Instead, just going on to the next token if it encounters what would have been an error. It'll return a nil instead of erroring in those cases. We will do that next time. Thank you so much for watching. I appreciate you. I will offline work on just kind of fixing up the kinds and getting it to match more with the The ASCII styles, I don't actually know if I need to do that at all. Maybe I'll just make a table at the end that maps to the ASCII styles. Maybe they shouldn't necessarily match APIs. Although I think it'd be better if they matched APIs. So I'll consider that. Thank you so much for tuning in.